Okay, we've still got a few people trickling in, but we're going to go ahead and get started today. My name is Sean Maurer. I'm joined today by my colleague Ryan Siegel. We're going to be covering some information on COMcheck and REScheck to know for energy code compliance and how to use that software. Uh, some quick housekeeping notes before we get rolling with the presentation here. If you do have a question for us, please ask at any time by using the Q&A window. If you hover at the top or bottom center of your screen, you should see that Q&A bar pop up. If you enter your questions there, it helps us keep track better whether we've answered all the questions or not. If you do enter a question in chat, we may get to it or we may miss it. So using that Q&A window just helps ensure that we answer your questions. We will also have some poll questions as we go through the presentation to help check your understanding and make sure that we're covering the material effectively. Our presentation today will be able to provide ICC education credits and AIA education credits. What we will do is when we follow up with attendees with an email with a certificate of completion for this course, that will also have a link to a form where you can provide your AIA member numbers and you can request ICC and AIA credits. So we'll do that. It's a little bit easier than requesting that attendees send us an email with that information. Things that we're going to be covering today: understanding when to use COMcheck and REScheck software, understanding the basic functions of those software tools, understanding the construction documents needed to complete a compliance check and learn how to enter that data into COMcheck and REScheck. There are some different construction assemblies that have some special requirements, and understanding the output reports and how to address non-compliance by looking at those reports. A little bit of background information about us here at SEDAC. We are an applied research group at the University of Illinois in Urbana-Champaign. We assist with buildings and communities in achieving energy efficiency, saving money, and becoming more sustainable. Our mission and goal here at SEDAC is to help reduce the energy footprint of Illinois and beyond. Our presentation today is sponsored by the Illinois State Energy Office at the Illinois EPA, as we would like to thank them for their sponsorship and for supporting our endeavors here with the Energy Code training program. Our program does offer technical support. If you have questions about Energy Code compliance or issues or understanding the code, please feel free to reach out to us at energycode@sedac.org. That is our preferred method of contact. It gives us time to research your questions in detail, converse with other members at our office that work on the Energy Code team, and give you the best possible answer. We do also have a 1-800 number listed on the screen there. If you need a quick response or it's a simple question, then we can provide a quick answer if you've got pressing timeline or something along those lines. We also have a number of online resources at our website, smartenergy.illinois.edu/energy-code. And that includes links to former presentations, workshops, and webinars, as well as smart tips and other helpful information and resources. As we show here, we do have links to all our previous workshop recordings and webinar recordings. We have online self-paced courses to help educate yourself on the energy codes that are continually under development. We're adding courses on a regular basis to that link. And also we have a link to our technical support resources, both the email address and that 1-800 number. We also have links to Energy Code resources. We have direct links to the most current version of the Illinois Conservation Code on our website. When the state of Illinois adopts the new 2021 IECC, we will update that link to that most current version of the code. We also have links to frequently asked questions that we get so that we can provide that information back to you in an easy to digest format, and links to the useful websites such as the Illinois amendments and the Chicago building codes. You can see those links here on this page. Again, so that you don't have to remember these complex links, we have those directly linked on our website for your convenience. And again, as these are updated with the new versions of the code coming out in the next few months as the Illinois is working to adopt the new 2021 IECC and add amendments to that. We will update these links to those new locations when they become available. This webinar is part of a series of webinars. We wanted to let you know what we have coming up on our schedule this year. In September, we're going to be going over the differences between ASHRAE 90.1 and the IECC in regards to envelope requirements. And then in October, we'll also be reviewing the mechanical differences between ASHRAE and IECC. We'll have a presentation on residential load calculations, how to do those properly using the Manual J load calculation software. There's a speed sheet for that, and the Manual J workbook as well. And then in November, we'll be covering the differences between ASHRAE and IECC lighting and electrical. And in December, we'll be doing the differences between the performance-based compliance paths between ASHRAE and IECC. So we do hope you'll join us for those. There'll be a lot of information in those that should be helpful for a lot of designers. So getting into COMcheck itself, looking at the overview of that particular software program. Things that we look at here are going to be very similar in the REScheck software that we'll cover later in this presentation. But there are two different versions of the COMcheck software. There is a desktop version, although they are planning on phasing this out. They will not update it with new energy codes. I'm not sure when that phase out is slated to begin for COMcheck, but it has already begun for REScheck. You will not be able to do compliance for REScheck with the 2018 IECC unless you're using the web version. This is just a thing that makes it a little bit easier for the COMcheck and REScheck websites to continually maintain updates and new codes and fulfill requests to do site-specific codes as well. It's easier to have those linked on a website than to continually update software that then needs to be downloaded and make sure that clients have continuous updates sent to them for those packages. So that's why they're moving to these web versions. They'll also will enable sharing of projects. It's a little bit easier to take a project if you've got a template building or something like that, and you've got multiple agencies using that template. You can share previous compliance forms for those facilities through the web version. It's a little bit easier than using the desktop version. Just a process overview of how COMcheck works. It takes the mandatory provisions from the envelope, the HVAC sections, water heating sections, power, lighting, and other sections of the IECC and ASHRAE codes, and puts them into a compliance software program that allows you to conduct trade-off analysis or direct analysis of the prescriptive options for the code. COMcheck does not allow you to do energy cost budget analysis through the performance path. It is simply a program to do the trade-off UA compliance path using the prescriptive options in the energy code. The process flow overview for using COMcheck: you start off with general project information. You're going to be gathering drawings and specifications, using those to fill out basic information like the site information for the project, whether it's a new construction project or an existing building that you're doing a renovation to, and certain details about building areas and things of a general nature for the building. Then it starts working you into the detailed inputs for those different components of the building. The next section is the envelope components. It's probably the most complicated section to enter details for, especially if you have multiple different assemblies in a building and multiple different orientations. We've seen some of these COMcheck forms to get quite lengthy. The next section after that is the lighting. There are two methods to complete lighting compliance: either the building area method or the space by space method, and COMcheck supports both of those. Then you start entering the mechanical information. Unlike the building and lighting envelope, building envelope and lighting sections, the mechanical section is a little bit lighter version. It's meant for basic compliance checks of your fan power ratings. And then rest of mechanical compliance is conducted through the reports and checklists at the end of the program. And then once you've completed all your data entry, you do get a compliance report that outputs from the program, which you can review and ensure proper compliance has been met for all components of the code. So this is just a basic look at the project entry. This is the first screen you're going to access on the COMcheck form. Key thing to be aware of, it does default to a certain code version. I believe it's the 2009 IECC as the default selection. So make sure that when you enter this program, the first thing you check is that you have selected the proper energy code for your project, be it the 2018 IECC or the most current version of ASHRAE, whatever you're using for your project. Otherwise, you can throw off your compliance checks throughout the rest of the report. So very important to make sure that you're using the correct code first. Next things to enter are the state and city. Those are going to help determine your climate zone for the project. And again, if those are incorrect, it's going to throw off your compliance reporting. And then you're going to be selecting your project type, whether it's new construction, an addition, a renovation project. They can all be analyzed through COMcheck, but it's important for the program to know what kind of project you're inputting there for compliance purposes, as that does impact what the code official is going to be looking for in the reports. Building area types, the next thing to be entered. So if you're doing, mainly this is going to impact your lighting sections of the report. So these lighting areas, if you're doing the building area method, is going to define what those building areas are. If you're doing the space by space method, you're going to be entering each of those spaces here with general information on the area that they cover, whether they're conditioned or not, and what the initial watt per square footage is needed for that building area will then be pre-populated so that COMcheck can do an analysis later based on your inputs, whether you meet that code compliance or not. The last thing is you're going to be selecting is your efficiency package option, whether you're doing enhanced lighting design, efficient HVAC equipment design, those bonus packages that are listed in the energy code in the IECC that give you that 110%, that little extra energy efficiency. You select that option here, and again, that's going to impact some of your choices later on in the program. So here we kind of cover what some of those limitations are. As an example, if you select a high performance HVAC system as your efficiency option, it does limit what types of equipment you can select in the HVAC section later on in the program. It won't allow you to put in constant volume systems or mixing VAV boxes because those aren't considered high performance HVAC systems. You'll be limited to VAV type systems and other high performance systems like heat pumps, things like that. Another thing to be aware of, I believe this has been corrected, but earlier versions of COMcheck, if you selected the reduced lighting power option, limited you to using the building area method. This was a holdover from older versions of the code that had that limitation. The 2018 IECC does not have that, and I believe this has been corrected and is no longer a limitation. So you should be able to use the space by space method along with that reduced lighting power. But if you do have an older version of the desktop app, make sure you check that. You may need to update your desktop version. So before we move on to the next section, we're going to launch a quick poll question here. When would you use COMcheck and REScheck? For all your projects, and whenever the code official says to, projects where you want to do trade-off analysis, or when you complete an energy cost model. Let that poll run for a few minutes here and see if we have any questions come in through the chat or the Q&A. Okay. Don't have any questions come in yet. We haven't gotten into too many details. We'll let this poll go a couple more seconds. Looks like we've got most of our responses in here. So we'll end that poll, share the results. So it looks like a lot of people selected all projects. For COMcheck and REScheck, you're going to want to be using it for projects where you're doing a trade-off analysis. You don't want to do it necessarily for all projects. If you're doing a performance model, you're going to be turning in full energy models instead of a COMcheck or REScheck. So you're not going to use this in every situation, although it is very common for a lot of projects. We do see that it is probably the most common compliance path, but it's there for that prescriptive compliance path documentation when you're doing those UA trade-offs. All right, so I will turn the presentation over to Ryan to cover the envelope sections of COMcheck.
Well, thank you. And we do realize that for many people, you probably do end up using it for, the vast majority of your projects. So saying all projects may have not been totally fair on our part. But as far as moving over to the envelope section for COMcheck, something that's very helpful that we find is for designers to build takeoff sheets. And this, you'll probably end up having to develop your own because COMcheck doesn't have an integral one at this point in time. Again, as they develop future versions and update the web entry, they may add some additional features, particularly something like this, which is commonly found in REScheck, but not yet available in COMcheck. And so going through it and doing all your detailed takeoffs, and as Sean noted earlier, this can be one of the more not so much intrusive, but this can take a fair bit of work. And so something to be aware of is for COMcheck as well as REScheck is the programs will go ahead and deduct the fenestration areas from the wall areas. So you go ahead and count the entire rectangle or whatever shaped wall area, include the entire thing, and then the programs will go ahead and deduct the fenestration back out. So rather than trying to calculate this yourself and figure out, okay, well, I have to remove this little hole here and that little hole for the windows, the programs will do that as well. So one of the big things as you're going through is making sure that you're aware of what all the program is going to be asking for. And for some of these, you do have to include the direction. And so being aware and perhaps generating these takeoff sheets for your own office, as far as making sure that you put them kind of in the same order in which they're going to appear in the COMcheck. And what this helps you to do is when you compare your takeoff sheet to the COMcheck entry, it may help you identify if you perhaps missed one of the lines as you're going through in doing all the data entry, because understanding and copying all of this over can be fairly dramatic. Now, if orientation is not required for your particular building model, then that can dramatically simplify this. There you can see all the different walls and which orientation they are, which building type they apply to. This also, we're noting here that the orientation is predominantly used if you have, you're dealing with solar heat gain coefficient trade-offs or some of the other particular entry areas. And so being able to simplify that down substantially can be very beneficial for you. So in here, we're seeing this, we've got at least 4 different wall types in each orientation. And so having to, rather than having to have 16 lines for the 4 different wall types for each of the 4 different orientations, being able to simplify that down to 4 can be very helpful. So as you're going through trying to make sure that you're doing this fairly, making it as simple as you can for yourself. Something that we see here is as you're going through your compliance check, the software will go ahead and update the compliance percentages as you are making updates and making entries. One way that this can be beneficial is if you put in an input that you believe is better than as specified in code, and the compliance gets worse, then you may need to go back and double check. Perhaps the input was placed in the wrong spot, or perhaps a decimal point was in the wrong spot. And conversely, if your compliance percentage improves when you have made an input that should not be as good as the prescriptive tables, then again, that kind of helps trigger that in the back of your mind saying, wait, that should have gone down and it went up. Did I put this in the wrong spot? And what we find is too often people rely too heavily on the results of a REScheck or a COMcheck and just looking at it and saying, you know, if it's green, it's right. If it's red, it's wrong. And we've also observed this. This is also something we help call out for code officials and other plan inspectors, is checking to see, you know, this is a fairly easy way to identify perhaps improper use of the software tool, where people are trying to explore and identify what is the least, the building that complies just as with the bare minimum, because these are calculating as you go. You know, if you go through and you identify and see, you know, envelope meets with 0% margin, that may not, this may not be accurately reflecting what is on the design documents. And it's okay to understand where your inputs and your sensitivity for different things, but being aware that, you know, what you are putting into the software program is accurately representative of the design. You know, a common phrase out there is, you know, garbage in, garbage out. So here we're showing how one might deal with curtain walls, because COMcheck does not have default values for curtain wall assemblies, and curtain walls can be dramatically different depending on their construction, as well as, to be totally honest, installation. And so what we're noting here is making sure that you're aware that you're using the assembly U factor and not the center of glass. It's not uncommon where you'll see two U factors for the assemblies, and frames are typically much lower performing than the glass itself that is installed. And so if you do have two U factors published, you're going to be looking to use the lower U factor, or the lower U factor is likely to be the center of glass, and the higher U factor is the assembly U factor. So that's the one that you would use, is the higher U factor. And again, being aware, because U factor is inverse of R value. So as the U factor goes up, the R value will go down. So with that, I believe we've got another poll question to check in as we're going.
Launched. So what are some basic functions of COMcheck and REScheck software tools? Demonstrating code compliance, generating checklists, looking up prescriptive requirements, or figuring out how much leeway there is in a design.
We did have a note, I believe we'll talk a little bit more about later on, as far as looking at REScheck, as far as additions and alterations, because additions and alterations typically are not using a simulated performance alternative path or something of that nature. Those are typically just prescriptive. So we'll perhaps touch on that a little bit more later on, as far as how that might be used.
Looks like we got most of our answers into our polls. We'll share those results.
All right. So most people demonstrating code compliance. Yes, that is definitely a function of COMcheck and REScheck. Second, looking at generating checklists. That is also a very good function of COMcheck and REScheck. Also, we may talk about this further as we go, is making sure to make good use of comments section. That's a great place to insert locations of specifications. So if you're saying, hey, this is compliant, see sheet A3, this is going to be your cutaways for the envelope section. That's a great use of the comments feature. REScheck and COMcheck do not really allow you to look up the prescriptive requirements themselves. That's where you end up having to go to copy of the code book, which we do like to call out that the International Code Council is very good at putting their codes, making them available for free to the public, as does ASHRAE. The ICC actually does a better job of making those searchable too, so that can be helpful. And kind of as we alluded to, figuring out how much leeway there is in a design, that kind of touches more into that adjusting your model to see how much leeway. That's really not what the program's designed for. With that, I'll turn it over to Sean to touch on COMcheck and lighting.
All right. So as we noted before, depending on what you inputted at the start of the program, COMcheck does pre-calculate what your allowed wattages are for the building area method and the space by space method. In this particular example, we're looking at the building area method, and it's a library. And so the allowance has been calculated based on the square footage of that building and the efficiency package selected. If you selected high efficiency lighting as the efficiency package, it would slightly reduce your allowed wattage here based on that efficiency package reduction of 10%. What you're doing here is you're entering all your different lighting types, how many lamps per fixture you've got in that lighting type, whether it's an HID, an incandescent, compact fluorescent, what the wattage is for the entire fixture. You're not entering in bulb wattages here, you're entering in the fixture wattage. So you're going to be accounting for any ballast factors with that wattage. And then you're entering in the number of fixtures serving that area. If you're doing the building area method, that's likely going to be most of the building. If you're doing the space by space method, you're going to have multiple sections listed here, and each section is going to have an allowable wattage calculated ahead of time. And then as you fill in your lighting components, it's going to be calculating what your proposed wattage is and comparing that to the allowed wattage. As we're seeing here, if you're doing a lot of LED lighting or the high efficiency linear fluorescent lighting, it's fairly easy to get decent compliance results with those lighting types for a building. I think something to be aware of is there are 32 different building types listed in the 2018 IECC, and they are all carried over to here. And there are also 97 different space types, and they've all been imported here. So you've got a lot of selection and design capability with the program to track the different lighting types. Something else that you'll be tracking here, kind of highlighted on the screen, some types of lighting that are used for safe egress, exit signs, safe passage lighting. Those are exempt from the lighting power requirements in the code. And so you do have the option to enter those into the program and then note them as exempted lighting. Again, this is strongly recommended that you do this instead of just skipping entering them. That way your code official has documentation that you've got this lighting in the building and it is exempt. So we do recommend that even if you have exempted lighting in your building, don't skip over entering that in the program. Enter it, make sure that exemption is documented, and that helps your code official track those exemptions and make sure that your lighting is properly documented between your drawings and what you're inputting into the COMcheck program. Looking at exterior lighting, the exterior lighting zone selections is going to determine what your watt per square foot allowance is for exterior lighting zones. You can select that up at the top. This corresponds to the zone 1 through 4 options in the energy code. They've broken them out into the descriptive versions of each of those. So you can see there's a neighborhood or business district that corresponds to the zone 2, where you've got neighborhood business lighting options. Residentially zoned areas is that, I'm sorry, zone 3 for the first one, zone 2 for the residential. High activity metropolitan commercial district, that's at zone 4. The light industrial area is also a zone 4. And then the developed areas on forest land and rural areas, those are those zone 1 options for your lighting. What you then do once you've selected that exterior lighting zone is you're entering in what different exterior lighting areas you have: parking lots, sidewalks and walkways, entryways to buildings. If you've got like in this particular instance, we're going to get a library. If you've got a night drop-off area, book drop slot, that has a particular lighting requirement. So you're entering in each of those exterior lighting zones, essentially, and then inputting what lighting you have inputted for that area. And the program is going to calculate, based on the lighting zone selection, what your allowable wattage is versus what your proposed wattage is. And it also notes here whether that wattage is tradable among other zones or whether it's non-tradable. You have that fixed limit there. You can see that highlighted in red. There's a non-tradable zone listed here for facade lighting. And so those are important to document and make sure that you're meeting proper compliance. I believe we'll move on to the mechanical section. For mechanical systems, what you're entering here in COMcheck is the different fan systems in your facility. So you're entering on the main screen for the HVAC system what type of heating and cooling coils you have, whether that has an economizer attached to it or not, if it's a multi-zone system, whether it's a VAV type system, single duct, dual duct, there's different options there. You're entering in your heating and cooling plants if you've got central chillers and boilers, and your service water heating systems. So these are all getting entered on this main screen. And then on the far right here, you can see a fan system details column. There's a separate input screen for fan system details that we'll get into on the next tab here. This is where COMcheck is really going to do a analysis for compliance for your systems. This is where you're going to get a pass or fail. And it's analyzing whether that brake horsepower listed for that system meets the maximum allowed per the code. Again, on that main selection screen, it's important to have the proper code because they have upgraded these brake horsepower requirements over time. If you have the improper code selected, you might find your compliance is incorrect. As you're entering these fan system details, if it's in compliance, you'll get a green check mark. If it's not, you'll get a red X next to the fan system. You can see displayed on the screen here. Things to be aware of as you're entering details. We'll touch on the next screen here. You're going to include all supply fans for a single system. So if you've got an air handler that has a supply fan, a return fan, and maybe has an associated exhaust fan that's tied to it for spaces that air handler is serving, all those fans get entered under the single fan system. So you can see here, this particular unit has a supply fan and a return fan. An important thing to note is that your allowable horsepower is based on your supply CFM. The return CFM and any associated exhaust CFM with that fan system. If you've got fan powered VAVs, those fan powers also get included in this. Those contribute to your total horsepower, but any CFM that they're moving is not included in that design air volume calculation. As you can see on the top right corner here, that's because the supply CFM is what's being used to calculate your allowable horsepower. The idea being that if you've got a supply fan with a return fan associated with it, the supply fan's not moving the total volume of air out through supply and then pulling it back through the return so its horsepower can be reduced, and then you're compensating with a return fan as well. So in this particular instance, having those two fans together resulted in this not being in compliance. But it's important to be aware that your supply CFM is the determining factor for what your maximum allowed horsepower is. Something else to be aware of is the fan efficiency grade listed on the right side of the table here. This is not the efficiency of the fan motor. This is the fan efficiency grade that comes from the AMCA. And this determines how much of the actual mechanical energy going into the fan wheel is converted into moving the air with the fan itself. This is one of those components in the energy code. You have to have a minimum fan efficiency grade. So that efficiency is tracked here in COMcheck for those compliance purposes. So important to be aware and not get confused on that. We have seen some people enter the motor efficiency there. That should be the fan efficiency grade, not the motor efficiency for the fan. There is an option to enter in fan brake horsepower instead of doing the total horsepower for the motor. Using the brake horsepower method gives you a little bit more flexibility with your systems. What we've included on the right side of the screen here is a table of the different adjustment factors that can be included when you're doing a brake horsepower analysis. This allows you to account for things that are going to add additional pressure drop in your system, such as advanced filtration. If you've got energy recovery loops in that fan system, those are going to add pressure drop. And so if you need to document more than just a basic fan system with your MERV 8 filters, the fan wheel, your heating and cooling coil, if you've got more than that in the system, you're going to benefit from having the brake horsepower design option here. Showing at the bottom left is just the slight difference in that fan power calculation. The supply CFM component is slightly reduced because you're not counting for the filters and things like you are with the fan horsepower system. But then there's an adjustment factor added on to that supply CFM calculation. And those adjustment factors are listed here in the table. So I believe we have another poll question before we move on to our next section. And we've had a few questions come in that we'll address. So our poll question here is, when looking at the output reports, actually this may be a little bit early for this poll. We haven't touched on the output reports yet. So we're going to end that real quick. That'll come up in the next section. Sorry about that. We did have a question come in before we move on can you please review the sort of project factors that would trigger performance of a COMcheck or REScheck? What project factors would negate the need to perform a COMcheck or REScheck? So if you're following the straight prescriptive path, where you're just following the prescriptive requirements of the code, you don't need to do a COMcheck or REScheck for that. You could do a compliance checklist based on the energy code requirements. And if you're doing the performance path energy modeling, where you're documenting through an eQuest model or train trace, carrier HAP, those programs that do whole building energy calculations for performance analysis. If you're doing that performance compliance path, then you don't need to do a COMcheck or REScheck. COMcheck and REScheck are for specifically if you're doing the prescriptive path with UA trade-offs. It allows you to track those trade-offs more easily instead of having to calculate it manually. We did have a question about when inserting a storefront system, the required assembly number is needed. Hard to find an assembly number from a storefront supplier. So I believe this is referring to the NFRC assembly numbers for those storefront assemblies. Correct me if I'm incorrect on that assumption. I'm not sure what the assembly number. I think what we were referring to was on plan drawings, if you've got multiple different storefront types, you've got an assembly number. It's important to document those as part of that input so that the code official can track the different areas for those different assemblies. that may be what I was referring to there. But if you're referring to the NFRC things, usually for storefront windows, that's a not a readily available number, as storefronts are usually done and assembled by component. You have to, there is an NFRC program, the component modeling program, where you would reach out to an NFRC approved vendor, and they do the total calculation for your U factor, solar heat gain coefficient for the specific assembly of parts. We'll follow up with you with an email on those specific details, as I'm not recalling them off my head in detail right now. But there is a way to get that NFRC values, and I'll follow up with an email to you specifically. I will turn it back over to Ryan to cover the COMcheck checklists and reports.
So COMcheck does go through and develops a lot of different checklists and reports, and kind of as I had alluded to earlier, here there's provides several opportunities for either plan references and page and section numbers, or other ways to leave notes. And so this is a good thing to go through and identify, you know, for a plan reviewer when they get the plans in, where can they go find the specific information to verify, you know, that what you placed into the COMcheck program matches what is in the plans or the specification documents. So that's very helpful. We've spoken with many plan reviewers that appreciate design teams that do make good use of this, because it does allow them to quickly check through and verify some of this. And something else that this also allows for is a project team to you know, demonstrate, you know, that, hey, we are, you know, somewhat professional in this. We don't just slap it together and get it out the door. We do take a little bit of care and time to make things a little bit easier. And also, if there ends up being some internal plan review before this goes in for final review by the code official or the city plan reviewer, it's always good to double check and cross check that you did include everything correctly. So does have several different output reports. Some of these will go through and either put your little red bar and say, you know, this fails because it's not as good as, it's worse than code. As we see here, the envelope fails, it's 11% worse than code. Another one towards the lower right, you see it's got a green bar noting that's 27% better than code. However, the HVAC and the fan efficiency, unfortunately, we have highlighted it here for clarity, but it does not spell it out and call it out as bold and as it does for the other areas. And so the HVAC system, the individual ones, you end up having to dig in and check and see, you know, for each air handling system, is the compliance a pass or a fail? Because it doesn't do the entire HVAC system, it's doing the individualized systems. So you could have a building, for example, it has 10 different air handlers and 9 of them pass and 1 fails. So that would still not be a compliant design because you do have one that failed, but it doesn't clearly call that out for you. And so that's something to be aware of as you're looking through this. You know, 11% worse than code, you know, that's obviously not good, but understanding, you know, if I see a design and it says, you know, it's 5% better than code or 10% better, you know, okay, that's understandable. If I saw here, you know, interior lighting power, you know, 30% better, that's not that unusual or uncommon. But being aware as far as if I see a design that says 50% better than code, either I may have forgotten to enter something, or there may be very efficient systems in that building, and that's good to call out. As far as if there's something unusually good about a design, go ahead and be upfront about this and say, hey, we did an excellent job in this area. So when the plan reviewer looks at it and says, oh, okay, yep, that jives with what I was expecting. So here again, going through and looking at and saying, okay, what was it that perhaps was there an entry error here? You know, when I have, I may have inadvertently counted some areas that were too high, or I may have double counted something. If I may have reversed cavity and continuous R value, I've seen that before. So there's a lot of different things here, and so identifying if I have a large area that's going to be worse than the value specified in the code tables, being aware that what is that impact going to be, and so I may need to have a substantial trade-off. So here also we're calling out that you may have, if you have curtain walls, there may be multiple window types. So here, you know, you might have window type 1 curtain wall, window type 2 curtain wall, et cetera, et cetera. And so here also we're calling out one of these. We even know what the series and specifications are. So being aware on those reports. Now I think we're ready for that poll question.
Yeah. Let's see if I can, I don't know if I can restart the poll. Let's see. There it is, relaunch. So when looking at the output reports to determine compliance, which envelope items should be investigated if there's an issue? Foundation assemblies, curtain wall assemblies, high UA value assemblies, or assemblies with steel frames? We did have a follow-up question on the NFRC component modeling approach, asking if we could send that to everyone. We can do that. What I will do is coordinate when we send out the compliance certificate information for this webinar. We'll try to include links to that component modeling approach information so that everyone has access to that. We did also want to note when we were talking about the different lighting zones earlier, the high activity metropolitan commercial in Illinois is likely only going to apply in the city of Chicago, in those main metropolitan commercial districts downtown where you've got a lot of shopping and stores there. There aren't many other areas. I don't think there's any other areas in the state of Illinois that would apply for that high activity metropolitan commercial area.
Yeah, so even the suburbs would not be included in that.
We did have a question, is there an option to enter task lighting? I will have to go back and check, but I believe there is. I'll go back through and check and send you a follow-up email. Yeah, I'll have to look into that. Not sure. Okay, looks like we've got most of our responses in for the poll here, so I'm going to share those results. Looks like most people got this correct. When you're reviewing for compliance, if you've got something particularly that's not in compliance, look at those high UA value assemblies. If you've got a high U value, that's a low R value. And if it's a large area of the building, updating that to decrease that U value is going to have the greatest impact on your compliance. So target those high UA value assemblies is the correct answer there.
So we're going to move over here to REScheck. So as far as REScheck goes, you know, we noted earlier that the DOE is looking to move away from the desktop versions. They made the first move with REScheck, where the 2018 IECC, or I guess the 2015 was the last supported version in the desktop version. So here in the state of Illinois, where the 2018 IECC is in effect, you kind of have to use the web version if you need to use REScheck. So just being aware of that. So it also helps as far as you don't have to try to figure out, well, am I using the most current version? Was there any updates to the software? Using that web version, you know you are using the latest and greatest version of it. So REScheck is much simpler than COMcheck for data entry, and some of this is due to simplified criteria, whereas in the commercial side, you have to deal with, what is your lighting budget and so on and so forth. Whereas on the residential side, it's just high efficacy lighting. So rather than wattage budgets, it's just high efficacy lighting. Now, REScheck does allow for the simulated performance alternative. So you may note here, you can select for compliance method either UA trade-off or performance alternative. So, however, this performance alternative is a fairly limited feature set. So if you're needing something that's a little more robust, you'll probably be needing to use a different program than REScheck for that. So, and again, as you're going through these floor plans and going through and getting your takeoffs, first thing that you want to make sure that you're doing is defining your thermal envelope. Here noting that we need to be sure that we are excluding unconditioned spaces. This may or may not be crawl spaces, may or may not be attics. So again, making sure that you know where your thermal envelope is. And so REScheck, the desktop version does have a takeoff sheet that you might be able to print out. So that may be something useful to grab the desktop version and then get that takeoff sheet, print out one of those, so that way it makes it a little easier as you're going through, trying to keep track of everything accurately. So by having that takeoff sheet, it can help reduce some of that transcription errors. So again, noting here, attics need to be very, very cognizant of these, particularly if you have complex geometries. Dormers would be an excellent example of some of these more complex geometries. Parts of this where do you have, is it just a fully conditioned attic, or is that attic outside of your thermal envelope? So anytime you also have sloped ceilings, partial height exterior walls, being aware of that as far as when you're doing your data entry, to make sure that you don't mistakenly include conditioned space that's not actually conditioned. So also, if you have your crawl space that's vented and unconditioned, then that would be outside of your thermal envelope. Crawl spaces, some of these may be vented and unconditioned. A lot of the trades we're seeing is moving more towards treating crawl spaces more like short height basements. Seal them up, manage the water, go ahead and ventilate them, and bring those into the thermal envelope. So doing unvented and conditioned crawl spaces, so mini basements, if you will. So this may also have for basements, and maybe even unconditioned or for conditioned crawl spaces, you may have above grade walls. And so being aware as far as if you have crawl spaces and basements, making sure that you're understanding where that is. Because these difficult geometries can really be a little bit tricky on you. So, Being aware here again, if you have sloped ceilings, those can be aware as far as how you're calculating that area, and making sure that you know, you're not double counting sloped ceiling with a flat ceiling. So walls where it just goes ahead and it's real easy, just assume the entire wall area and it will subtract off the fenestration. It doesn't have that same functionality when you're dealing with flat and sloped ceiling. So it won't deduct your sloped ceiling from your flat ceiling area. As far as project tabs, so going in, again, project location and type. As far as additions and alterations, what you're dealing with for additions and alterations is only the part that is the addition and the alteration. You are not going to input the, typically you will not be inputting the existing building unless you are looking to use the performance alternative. Then you're going to go ahead and model the entire building as it is with the addition. And you have to demonstrate that that entire building with the addition is fully meeting code. So that's one of those little things where you might model an entire building if you're doing an addition or an alteration, if you're needing that performance alternative. If you're able to do this through either just the straight prescriptive or prescriptive using the UA trade-off, then all you're going to model is the addition or alteration. So you're not going to model the existing under those conditions. So some of these also features in checking through, you know, checking all your ducts and air handlers, are they in the conditioned space? Ducts buried in the ceiling insulation. You know, any sunroom, is it thermally isolated? And so on and so forth. So as far as that goes, making sure, again, just checking that you've included everything. You know, here we have a raised or energy truss, raised heel or energy truss. So I might be able to offset some of the insulation there per the prescriptive path. You know, specifying, you know, is it 16 inches on center or 24 inches on center? That is going to matter as part of the modeling. And being aware, is this cavity or continuous insulation? You know, we have seen this, you know, mistaken where if generally you're dealing with cavity insulation, continuous means it is not interrupted by framing or structure. So being aware of that. Something that's very helpful as part of this is they do include some graphics to make sure that help guide you as far as the definitions and what are we counting where. So understanding the difference between depth of insulation and the wall height. You know, the wall height, does it include the band joist or not? Here they have been very good about calling out that the band joist is not part of the wall. That's part of the floor above. So very nice, nice and helpful through that. So here again, it gives you your compliance check. You know, 0.2%. That's, you know, the max was 434 and my design was 433. I made it by 1 point. That's probably going to be a little suspicious. So I'd probably be taking a hard look as far as, does this, you know, was the data entered? Does this match what's actually on the design? So we haven't even gotten to, was it installed per the design? You know, just does it even match the design? So orientation, again, on the REScheck, I believe it's only if you're dealing with the solar heat gain coefficient trade-off that you end up needing to deal with orientation on your components. So, several different things that are in the performance path reference design. So looking at mass walls and foundations and going through, there's a lot of things noting. Also being aware that REScheck, because this is using the model code and not any state-specific amendments, it is assuming air changes of 3 air changes per hour. It doesn't allow you to say I'm doing a tighter building. So again, this is some of the limitations of REScheck. Is it just makes certain assumptions that are not able to be changed. So if you are going to design for a tighter envelope, you're going to need to use a different performance tool than REScheck for that. So, and again, also here noting, high efficiency mechanical doesn't shift what it shows in the REScheck either. So again, just being aware of some of these limitations. If you are needing to use the cost model, look at another program for that. So with that, we've got one final poll question. What construction documents are needed to complete a compliance check? The envelope cross sections, mechanical schedules, lighting schedules, plumbing layout, all of the above, or none of the above. Had a question here regarding COMcheck and EV charging. EV charging was not added to the IECC. Upon final review, the EV charging requirements were found to be outside of the scope of the IECC. So those, while they were proposed and they were initially recognized as being in the code, they were later removed upon appeal. So that's something to be aware of.
We also had a question about when entering the fenestration type and amount, what dimensions do you use? You would use the rough opening for fenestration inputs. The reason being the NFRC rating for that window includes the window frame and things like that in the U factor, solar heat gain coefficient analysis of the window. So you would be entering the rough opening size.
And as far as our poll goes, looks like most everyone did pick up that yes, you do need all of the above because we're dealing with, for compliance checks, we are dealing with the envelope, mechanical, lighting, and potentially some of the plumbing for insulation. So all of the above there. Excellent.
We got a question about how are skylights calculated. So they're entered similarly into roof assemblies as fenestration is into wall assemblies. So you're not going to subtract out the skylight area from the roof area. They're entered very similarly to the wall area in a COMcheck and REScheck. And again, just as with windows, you're entering that rough opening and you're letting the NFRC ratings take care of framing effects and things like that with the window assembly. And then, is there any way to enter pump horsepower information? Let me look at something real quick. I did want to touch back on the task lighting question we got. That is not included in the calculation for lighting power density. If you look at C405.3.1 of the IECC, they have a calculation there for total connected lighting power. It does not include task lighting in that calculation. So if it is included in COMcheck for task lighting, it may be a lighting that is included under an exemption, as it's not included in that total lighting power calculation in the code.
Did have a question as far as estimating annual energy use. I believe I have seen that in one of the softwares. Again, because the software is not very robust as far as things that you can edit, as far as energy costs and energy consumption. It's really not well suited for that. So I believe REScheck, again, it does have it, but it's not very robust. As far as for the 2021 IECC, that is slated to, the amendments are presently in development for state of Illinois. Adoption of the 2021 IECC is slated to be next summer, either June or July of 2021 is presently the timeline on that. Again, that can be, that is subject to change at any point, but be looking for that probably summer of 2022 for that. And again, what that would be for permits, for permit applications dated summer of 2022, when that would be in effect. So if your project's in the middle of construction, it doesn't automatically change override.
We did have a question as well come in about entering pump horsepower information. The Energy Code doesn't have any specific requirements for pump horsepower for hydraulic systems. It's usually taken care of by the design of the system. It does have requirements for controls on those pumps though, VFDs and things like that. Those are included in the checklists for the program, depending on what type of hydronic systems you select. It'll input things in the checklist to check off for certain controls on those pumps. But there is no pump horsepower input because it doesn't need to be modeled by the program.
And the question as far as a drive-through window, that would be treated just as any other window would be. The only real difference there would be just your area, and you're probably only going to see one or maybe two of them in a building. So yeah, a drive-through window would be treated like any other fenestration or window, operable window.
I believe that wraps up all the questions. We've gone a little bit over on time, so we want to thank you for sticking with us through the presentation. As noted, we will include with the certificate of completion a link to input your AIA member numbers and request for ICC continuing education credits, so we can get those credits for you. And we'll also include information on the component modeling method for NFRC for storefront windows as well. So thank you all for joining us today. We appreciate your time. We hope the presentation was helpful.